Hello, welcome back to my channel. My name is Kenji. So what we are going to talk about is the exam prep of IB Physics. So the exam prep lesson and the regular lessons is actually different. When I was teaching a regular lesson, I usually will introduce the concept to my students very carefully and detailedly, and then go through some questions with them. But in exam prep course, what I'm going to do is that to teach my student how to get all the score which is in the IB Physics exam. So in this video, I'm not going to go through the very details of what the behind phenomena, but to teach the student how to answer the question coherently to what the question asks. So now let us begin. So let us take a look at this question. I captured it from some IB Physics past paper. It is, let us take a look. Part A, it said that when a monoclinic light is incident on a metal surface, the electrons are emitted instantaneous from the surface. Explain why the emission of electron is instantaneous. Now I will give 2 minutes for you to think about what is happening. Now, 2 minutes has already passed, so in order to explain this theory or explain this phenomenon, you have to know what is happening. Is there anyone know about what is happening? Yes, it is about the photoelectric effect. If you don't know about this topic, you are not able to answer the question. You are not able to make up the answer of it, right? So, in case some of you have already forgot what photoelectric effect is, I can show you this simulation, which you can also scan the QR code to get the simulation. Um, it is like that when the light is incidenting some light on the metal surface, the electron come out from the surface. This is what we call the photoelectric effect, but we are not going to go through the details of it. Let's just go back to the notes. So explain this question, what we are going to do is to state out the quantum theory of light, which is in that theory, the light is quantized as a particle called photon. Each with photon with each of them have the energy E equals to HF, and one photon can only hit one electron. So the electron escape right away. So for all of my students, I have to tell you that you don't have to remember the exact wording that I'm writing. Everyone should use their own wordings to explain this phenomenon. But when we are going to get all this V score, you have to answer the key concept that the examiner wants you to answer. So if the question gives you 3 marks, what this means is that there are 3 key important concepts. All right, so now let's take a look at my response. So the first mark comes from the light is quantized as photons. The second mark is that the energy that the photon is carrying. is E equals to HF, which will give us 1 mark here and there. And then in the next part, so 1 photon can hit 1 electron, which will also give us another mark, which is how these 3 marks are come from. You have to answer these 3 key points in your own wordings. Now, let us go to question 2. It also asks us to explain something. It asks us to explain why the energy of the emitted electron does not depend on the intensity of the incident light. Now, I will give you 2 minutes to think about it. 2 minutes has passed, so let's just take a look at the question. The emitted electron does not depend on the intensity of the light. So what does that mean is that in our daily light experiences, when the intensity of the light is larger, we are expecting more energy is hitting on the metal surface, then the electrons should come out faster. But the experiment showed that this is not the case. What is happening is that it's also about the quantum theory of light. It's about this point here. Since 1 photon can only hit 1 electron, which means that the electron cannot accumulate 2 or 3 photons energy. So and also one of the other thing is that when we are increasing the intensity of the incident light, because the energy is amount effect is fixed. What it means is that when we are increasing the intensity, we are only increasing the amount of photon only. So the intensity of the incident light is actually a measure of how many photons are there hitting the metal surface in each second. Okay. So now we are going to answer this question. It gives us 1 mark, so we only have to answer 1 key concept. So what we are going to answer is that the intensity is measure of the number of photon hitting on the metal surface. And then we will get that 1 mark. Okay. Now, let's just move on to the next question. In part B, is that it gives us more information about the monochronic light. The wavelength of that monochronic light is given with this length, and the work function of the metal is given by this amount of energy. So in part 1, it asks us to determine the maximum kinetic energy of the emitted electron. I will give you 2 minutes to think about it. Now 2 minutes has passed. Let us think about this question. So when the light hit on the metal surface and the electron escape, so I will draw a picture to show you what is happening. So a photon here, which is shining on the metal surface. When he hit the metal surface and the electron inside, the electron come out. So the energy of the electron is given by that photon. But initially, what is the things that is trapping the electron inside the metal? Is actually the work function or the electrostatic force, which is the energy required to let the electron escape from the metal surface is given in here. What we are going to do is that we are we are going to relate these three things: the photon and the work function and the escape velocity, or the escape or the kinetic energy of the escaped electron. So first of all, we will work on the energy amount of the photon. So we have the formula E equals to HF. H is a constant. So if I using Casio calculator, this constant can be find out by pressing shift 706. But also you can find out this constant in the data booklet. So, but the question give us the wavelength, not the frequency. We will have to convert the wavelength to frequency by this formula: C equals to frequency times the lambda times the wavelength. So by transporting the terms, we will have this. And then we will plug in the numbers. And we will get the answer. Once we have the energy of the photon, the maximum kinetic energy of the electron is the photon energy amount minus the work function, which will be this amount. Okay, this is just that simple. Of course, some students may prefer to do it very mathematically. Indeed, when I was doing this question in the first time, I do it in a very mathematical manner. So I will list out this formula. Maximum kinetic energy is equals to the energy gained from the photon minus the work function. This is okay, because this formula is essentially the same with this construction. So how that 3 mark come from is that you have to write out E equals to HF, which has 1 mark, and then relate the work function and the kinetic energy by this formula. This will give us another mark. The final answer is also 1 mark. Okay, if you answer in the question in this manner, you will directly get 2 marks by this equation, and then the final answer 1 mark. So let us go to the part 2. Part 2, the metal surface has the dimension like this, and the intensity of the light incident on the surface is given by this power is per unit area. And on average, 1 electron emit for every 300 photon, and determine the incident electric current leaving the metal surface. I will give you also 2 minutes to thought about it. Now, I think 2 minutes has already passed. So in this question, it asks us it asks us the initial electric current leaving the metal surface. It would be great if we have the number of electrons escaping from the metal surface. If we want to find the number of electrons that is escaping from the surface, we need to know the number of photon which is hitting on the metal surface, number of photons. How are we able to find the number of photons is that we have to know how many energy is heating on the surface, and then we will define it by the photon energy amount, divided by photon energy. So now we have the draft of how to do this question. Let's just take a look at what the information that we have. Now we have the intensity of the light, which is given here, but in per unit area. So we have to multiply it with the area so that we get the energy. So, and also the energy is written in watt, not joule. What does it mean, watt? 1 watt is equals to 1 joule per second. So in 1 second, how many energy heating the metal surface is like this. The total energy is this intensity. I will denote this as I times the area, then times the time. Then we will plug in the information. The intensity is like this here. The area of it is also given by the question. Remember to convert the unit. And then how about the time? The question doesn't give us the time. To make it simple, for those situations, if we don't have the time, just consider what happened in 1 second. We will take the time as 1 second. And we will get the answer right away. Now, with each second, there are that amount of energy heating the metal surface. Now we can convert these energy amounts to the number of photons. The number of photons is the total energy divided by the the energy amount of each photon, HF. And then we will plug in the number. This number comes from the previous question. And we will have the number of photons be like this. And then once we have the photon, we can now work out how many electrons escape from the metal surface. Every 300 photon will kick out 1 electron. So the number of electron escaped is the photon numbers amount divided by 300. The value is somewhere in here. So with the electron, we can now convert it back to the current. The current I is equals to the number of charge, which now is not the number of electron times the electron charge, and divided it by the time. What is the time? Is 1 second. We will divide it by 1. So the answer will be this. It is just that simple. So in this question, it's gives us 3 marks. So what you need to do is that you should be able to convert the intensity into the energy, which will give us 1 mark. And then secondly, you need to convert the energy into the number of photons, which will give you another mark. The last mark come from here, this whole section. You can do it in one equation or do it separately, but it will just give you 1 mark. So convert the photon into the current, which will give you another 3 other mark. You will totally give you 3 marks. This is just that simple. Okay? Is there any question? No, now this is the end of the class. I hope that all of you can enjoy the video and can have a better understanding of how to answer the question coherently. So see you next time. Bye bye.